This video is going to go over a couple of questions on the verbal stem free response question medley. And I'm looking at question 2 and part D. It states that there's a third particle Q that moves along the y-axis perpendicular to the path of particles P and Q. The position of particle Q at time t is given by Q of t. At time 2, Q of t is 4, Q prime of 2 is 6. Describe how the distance between particles Q and R is changing with respect to time at t equal 2. Okay, so I wrote down some of the given information. Q of 2 I know is above the origin since it's at 4. Its position is at 4 at time 2. So it is rising. Okay, because the derivative is positive, derivative of Q. I also know that R of t, given from what they gave us at the beginning, moves along the x-axis, and it wants to know how the distance between Q and R are changing. So we know, given information right here, that this is how Q is, and at 2 it's at 4 and it's rising. I can also find out R of 2 from the given information. R prime of 2 is negative, so I know that is moving closer to the origin, and I know that this distance is 5 at time 2, this is 4 at time 2. So I want to be careful and not think it's automatically a 3, 4, 5 right triangle, because the hypotenuse has to be the longest side. So that a hypotenuse is the square root of 41. So I'm going to use the Pythagorean theorem. I'm going to do the derivative. All of the rates, like all of the sides, are changing, so we need to include their chains. I divided everything by 2, and then R was 5, that was that horizontal distance, and was moving at a rate of -3 by taking the derivative of R at 2. And then we have 4, which is Q, and we know that its rate is 6. We know the hypotenuse is root 41, and we're trying to find the rate of change of that hypotenuse. Okay, so that's how I got that one. Okay, the next question is on that same worksheet, but it was number 3, the last part. Okay, so it was number 3E. So it gave us a function, the square root of 25 minus x squared. We really want to know what that looks like. It's a semicircle. Think about if we had the equation of a circle of radius 5 and solved it, we'd get a positive and negative square root. So the positive square root is the semicircle that lives above the x-axis. So part E wants us to integrate and find the value from -5 to 5 of 6f of x plus 3 dx. So the first thing that I did was took out the scalar and separated. So f of x was given in the problem to be this square root of 25 minus x squared. So the area under that curve is 1/2 pi r squared. So in this case, the radius is 5. I'm going to multiply by that scalar 6. Now this other one you could do a couple of ways. I just thought that from -5 to 5, it was at y equal 3, which was a horizontal. So it's a rectangle. Of course, that's not to scale, but a rectangle of 10 times 3. Now, if you didn't remember that, you could just integrate 3 and then use the fundamental theorem to get 30. And then when you add it up, you'll get that answer.